Hi, welcome to today's NPP Meet the Author interview. I'm Sophia Hupalo, the NPP editorial intern, and joining us today are Chloe Jordan, the special projects manager, and Carrie Martinowicz, our social media editor. And today we're speaking with Briana Chen. Briana Chen is a graduate student at Columbia University in Christine Denny's lab. My apologies. Her research focuses on identifying sex-specific neurobiological mechanisms that can be targeted with prophylactic agents to promote stress resilience and prevent stress-related maladaptations that are relevant to depression. So today we're chatting with Briana about her research related to her NPP publication, which came out last May. And her paper is called Sex-Specific Neurobiological Actions of Prophylactic RS-ketamine, 2R6R hydroxynorketamine, and 2S6S hydroxynorketamine. So check out her article in the video description below and reach out to us on Twitter if you have any questions. So to start us off with our first couple of questions, I'll hand it off to Chloe.
Thank you, Sophia, and thank you so much, Briana, for talking with us today. So our first question for you is, what is one finding in your paper that you're most excited about, and how does it influence current thinking in our field?
Yeah, so there are actually sort of two main findings that I was really excited about from this paper. And the first one that I have to point out is obviously sex differences. So in the paper, we found sort of two main sex differences that I just want to highlight today. The first one is how these prophylactic agents alter fear behavior in male and female mice. So as we've shown before, RS-ketamine, it attenuated learned fear in male mice, and we also found that 2S6S HNK attenuated learned fear as well. However, in female mice, we found that none of the compounds that we tested altered fear behavior. And this is something that we've seen time and time again. And that is that male and female mice actually exhibit different fear behaviors. And so we're thinking that in female mice, perhaps the circuits that underlie fear learning and or retrieval are actually different than in male mice. And therefore, maybe that requires different targets if we want to prevent fear-related disorders in females. And the second sort of sex difference that I'd like to point out is the differences in dosing between male and females. So the effective dose of ketamine and 2R6R HNK was about 1/3 of the effective dose of the same drugs in male mice. And so there was kind of a possibility that if we hadn't tested a range of doses in the females, we would have thought that the drugs didn't actually work. So I think that it just goes to show that when we're studying sex differences, especially in terms of antidepressant or prophylactic drugs, we can't just sort of copy and paste our results from male mice. We have to be smart about it, and we have to adjust our approach accordingly. And we have to continue to treat sex as a biological variable and ensure that we're continuing to use female subjects in our research. And the second sort of big finding from our paper that I'd like to highlight is that we actually found a common mechanism that may contribute to the behavioral actions of prophylactic drugs. So we found that both ketamine and 2R6R HNK, which reduce behavioral despair in both male and female mice, both of those drugs reduced AMPA receptor bursting in CA3 of the hippocampus 1 week after injection, which is when we would typically expose mice to stress. And so even though ketamine targets the NMDA receptor and the targets of 2R6R HNK are still being worked out, they're still somehow converging to act and suppress AMPA receptor activity in a very specific region of the brain.
That's fantastic, and it's such an important message to highlight sex differences like that too, so thank you for sharing. Are you following up on these studies, and if so, what kinds of research questions are you pursuing right now?
So we've continued our work to try and find different drugs that prevent stress-induced maladaptive behavior in both male and female mice. Ketamine was the first drug that we've found. After that, we found 2R6R HNK, but we've continued to look at different compounds. And we've currently assembled a library of about 6 different compounds, including ketamine, 2R6R HNK, that enhance resilience to prevent a variety of stress-induced behaviors in mice. And these include 3 different serotonin receptor type 4 agonists, as well as an NMDA receptor antagonist derived from memantine that acts similarly to ketamine. And we've actually continued to find that these drugs, despite acting on very different receptors, all of them reduce AMPA bursting in hippocampal CA3. So I think that this points to some sort of convergent downstream mechanism that may be essential to the prophylactic actions of these compounds. And we're currently looking into this mechanism further.
Very cool. I'll let Carrie take the next two questions. Thank you.
Okay, thanks, Clay. I think the thing that I wanted to ask you is like about the background, like what led you to this research. And I guess based on your first questions, one thing I'm kind of interested in is specifically what led you to the, to really query the sex differences.
Yeah, so sort of just how I got into this line of research in the first place. I'm the daughter of immigrants, so I've always been very aware of and interested in how different environments can shape behavior. So when I came to Columbia, and I was fascinated by Christine's research showing that it's possible to prevent stress-related behaviors in female mice, and I really wanted to be a part of developing prophylactic compounds with the ultimate goal of developing tractable interventions to prevent psychiatric disorders. And what specifically drew me to sex differences is when I was in school, I actually went to an all-female high school, actually starting from second grade and onwards. And so I've always been very aware of women's health, women's issues in society. And I was astounded when I first came in to learn that we had only really tested prophylactic ketamine in male mice. And that's a big gap, right? Women are half of the population. They're also much more at risk for developing stress-related diseases such as depression and PTSD. And so I really wanted to address that when I first started in the lab. And that's what ended up drawing me into this research project.
Okay. And I guess you've done a lot of work for your PhD. And so we're wondering what's next for you. You must be close to finishing up, I would think. And so could you share with us what your plans are for next steps and where you're going?
Yeah, absolutely. My ultimate goal is to pursue a career as a principal investigator, hopefully studying the neural substrates underlying stress resilience. I'm going to defend my thesis next spring of 2022, and I'm currently on the lookout for postdoc opportunities. So if anyone's looking to add a postdoc to their lab with experience in systems and behavioral neuroscience with a focus on stress and psychiatric disease, please don't hesitate to reach out to me on Twitter or through my email.
Well, thank you so much. Yeah, and I'm really fascinated by your interest in prophylactic agents and, ensuring, doing really systematic studies that are, really important aspect of pharmacology, which is like dose dependency. And I can definitely relate to that as something that is very important in all areas of behavioral and circuit neuroscience research. And so I just wanted to thank you again. We all wanted to thank you again for chatting with us today. And I'm really, really excited to see what your next steps are and the kind of research that you're going to be doing, because it's definitely very important in the area of psychiatry. So thanks again, Briana.
Thank you so much for having me.
Thank you.
Thank you.